Hello, dear learners. Today I welcome you for exercise 1.2, part 2 of chapter number 1, and this is mathematics of grade 9. In previous lesson, we have solved first three questions of exercise 1.2, question 1, question 2, and question 3. In today's lesson, which is part 2 of exercise 1.2, we are going to solve question number 4, question 5 and question 6, and after that this exercise will be completed. So before starting question number 1, we first of all take the concept of negative of matrices, or you can say negative matrix. So if I explain you that what is negative matrix. A matrix in which we change the signs. For example, I have a matrix A and the elements in this matrix are 1, 7, minus 9, minus 11. If we change the signs of these elements, it is known as negative matrix. In other words, you can say that if we multiply minus with this matrix A, if we multiply minus with this matrix, the signs will be changed. It will be known as negative matrix. It will become minus 1, minus 7, plus 9 and plus 11. So if you see, this was the original matrix A and we have changed the signs. The positive sign of entry is going to be negative 1, and here if you see it is plus 7, it is changed to minus 7, minus 9 is changed to plus 9. So this is known as negative matrix. Now let's see what book says. If you see here on page number 7 of the book, negative of a matrix. Let A be a matrix. So suppose that you have a matrix A which is given here and the entries are 1, minus 2, 3 and 4. Then its negative means if we take the negative of that matrix, or you can say we multiply this matrix by negative sign, or minus A matrix is obtained by changing the signs of all the entries. We change the signs of all the entries. For example, this was positive 1, we make it minus 1. This is minus 2, we make it plus 2. 3 is positive, we make it negative 3. The entry is now negative 3. Similarly, this is plus 4, we make it minus 4. We have changed the signs of the entries. It will become negative matrix. And our question number 4 is related to negative of a matrix. Then in question number 5, we have the concept of transpose. So before starting the question, we also take the concept of transpose. What is transpose? In transpose, we change the rows into column or column into rows. For example, I have a matrix A. The elements or the entries of this matrix A is 3, 7, 1, and you can take it 30. So if I want to take the transpose of this matrix, I want to find out A raised to power T, which indicates that transpose of A matrix. It will be 3, 7, 1, 13. What we do in this, I have changed this row. In previous lesson, we have taken the concept of the rows and columns. This is a row 1. I name it as row 1. If we change this row into column, now it is a column. And this is row 2. If we change this row 2 into a column 2, it will become a transpose of a matrix. In other words, you can say that this is a column, you change this column in which the entries are 3, 1 into row, and this column into this row, it will become the transpose of the matrix. Now let's see what book says. A matrix obtained by interchanging the rows into column means to say that if we change rows into columns, or you can say column into row, it will be the transpose of the matrix. For example, if A is a matrix in which entries are 1, 2, 3, 2, 1, 0, minus 1, 4, minus 2, and we change, what we do here, we change these rows into column, that is 1, 2, 3 in row 1, we make it column 1, 2, 1, 0 as column 2, and row 3 as column 3. It will be your A transpose, or the transpose of this A matrix. And remember that transpose is always denoted by A raised to power T, A transpose. Same is the example here. Now let's move towards the questions. Question number 4. In this question, find negative of matrices A, B, C, D and E. So these are the matrices. We have to find the negative of these. So 5 matrices are given. I am going to solve only 3. Rest of the 2 will be your practice questions. So matrix A, D and C I am going to solve. In matrix A, the entries are 1, 0, minus 1. Question number 4. Matrix A is equal to 1, 0, minus 1. And we have to find the negative matrix. So in negative matrix, we change the signs. It will become minus 1 because it is here positive 1. 0 and minus 1 will become positive 1. 0 is not the negative or the positive one, it is always 0. So this is the A matrix. Now I am going to solve D part. In D part, the entries are minus 3, 2, minus 4, 5. In D part, entries are minus 3, 2, minus 4 and 5. Let me see again. Yes. So I have to find the negative matrix of this D. So what I do, I will change the signs. It will become minus D. So minus 3 will become 3, 2 will become minus 2, 4 will be minus 4 will become 4, and plus 5 will become minus 5. This is known as negative matrix of D. Now I am going to solve C part. Matrix C. And the entries of this C matrix are 2, 6, 3, 2. 2, 6, 3, 2. So negative matrix C will be minus 2, minus 6, minus 3 and minus 2. So this is the negative matrix of C. So in the same way, you have to do the remaining parts, that is B matrix and E matrix. Just simply you have to change the signs of this. If it is plus 3 here, if you see, you will make it minus 3, minus 1 as plus 1, 2 plus 2 as minus 2, and this will become minus 1. In this way you can find out the negative matrix. Now I am going to solve question number 5 of this exercise. In this question, you have to find the transpose of each of the following matrices. So 6 matrices are given. I am going to solve any 3. That is, I will solve A, and C and D1. So first of all, A matrix is 0, 1, minus 2. Question number 5. A matrix, and in A matrix the entries are 0, 1, minus 2. 0, 1, minus 2. And we have to find the A transpose. So it will be equal to 0, 1, minus 2. We have to take the transpose of this, and in transpose we change the column into row or row into column. So here we have one column, this will be changed into one row. So the A transpose will be 0, 1, minus 2. This is the transpose of A. In the same way, we are going to solve now part number C, C matrix. Entries are 1, 2, 3, 2, minus 1, 0. C matrix. 1, 2, 3, and 2, minus 1, 0. 2, minus 1, and 0. So we have two columns. We will change these columns into rows. This column will become row, or you can say this row will become your column. So C transpose is equal to 1, 2, 3, 2, minus 1, and 0. So this row is going to be your column 1, this row is going to be your column 2, and this row is going to be your column 3. So in this way you can find out the transpose of matrices. Now I am going to solve one more part, and that is D. In D you have the entries 2, 3, 0, 5. D matrix I am going to solve, and the entries are 2, 3, 0, and 5. If I take the transpose of this matrix, it will become 2, 3, 0, 5. Only what we have to do, we have to change this row into column, this row into the column. So this is your transpose of D matrix. So I hope so you are clear about this. Now we are going to solve question number 6, and this is an important question. In this you see that we have to verify that if A is this matrix and B is this, then A transpose of transpose is equal to A, and B transpose of transpose is equal to B. I am going to solve first part, and the second part is your practice question which you have to solve. If you face any difficulty while solving the second part, you may contact me. So first of all, I am going to write the matrix A and matrix B. So matrix A is having the entries, question number 6. Question number 6 of exercise 1.2. A matrix is 1, 2, 0, 1. 1, 2, 0, 1. And B matrix is also given, that is 1, 1, 2, 0. 1, 1, 2, 0. And in this question, we have to prove that A transpose of transpose is equal to A. Means once we have to take the transpose of A, then we have to take the transpose again, and we have to verify that either it is equal to A or not. So remember one thing, that if we take 2 times the transpose of one matrix, it will become as it is, as the original matrix is. So if you see here, you have matrix A, that is this one, that is this 1 2 0 1. If I take the transpose of this, first transpose A transpose, it will become 1 2 0 1. Now what I have to do, I have to find the A transpose of transpose. This is fine, the eliminated. Now we have to take the transpose of this. So it will be A transpose of transpose. It will become 1 0 2 1. So if you see, it is equal to A matrix. A matrix is, sorry, here we have to take the transpose as well. So if I take the transpose of this, it will become A transpose of transpose is equal to 1 0 2 1. So it is equal to A. In A we have the entry 1 2 0 1, and here it is 1 2 0 1, which is equal to A matrix. So you can say that A transpose of transpose is equal to A, and hence proved, or you can say hence verified. So in the same way you have to solve part 2 of question number 6. I hope so you are clear about these questions. Question number 4, 5 and 6 of exercise 1.2. If you have any difficulty, you may contact, and do not forget to hit the like button. Thank you.